Hi everyone, this is video 20 and today marks a really exciting day because today we're going to be starting to talk about something called data structures. And today's going to be an introduction to that idea, and we're also going to look at our first real data structure, the linked list. Okay, but before I go into that, I want to go over a few more details in Python, particularly because they're going to be used today in this video. So let's get straight into that. So in Python, you can actually do something called assert statements. And assert statements are useful because let's say you execute some type of code, like x is equal to y is equal to, x is equal to 5, y equals 10, all that stuff, and you want to make sure something is true after doing all this work. So what you can do is you can do something like assert x is equal to 5. And nothing's going to happen here because what this tells is like, hey, everything's normal. If nothing happens, that's good. No news is good news. But let's say I, for example, assert that x is something else that it's not, like this. This will throw an assertion error. So what this tells you, if you get an assertion error, you know something that you asserted didn't actually end up happening. So that can be help in finding your logical errors very quickly. Now, also something you can do is you can actually give yourself an error message. So you could give yourself an error message such as the following, like Houston, we have a problem, and we'll get assertion error, Houston, we have a problem. So if you have several assert statements, it's good to obviously give each of them a message so you know which one it's pointing to. And also, obviously, give it a good description, not Houston, we have a problem, because that doesn't really tell you much. So like here, I would say assert x is equal to 4, x should be 5. So that's the basic idea of that. And now, the next idea we're going to talk about is I'm going to define some lists, and we're going to talk about using is versus double equals. We haven't really talked about is, but it's not too bad of an idea. So what we can do is we can define a list as the following, and we can define list 2 as also the following. Oops. And so what we can do is we can say list 1 is equal to list 2, and this is obviously true because the elements of list 1 and the elements of list 2 are the same. So that's true. Now, the question now is, hey, is list 1 list 2? Like, are the identities equal? And this is actually not the case because list 1 and list 2 are defined as separate lists, even though they have the same elements. So there's a very subtle distinction. But if I do something like list 2 is equal to list 1, what happens? Well, we copy the pointer. Think about environment diagrams. I'm actually going to go over an environment diagram. We copy the pointer of list 1 to list 2 because it goes right to left. So now, if we check if list 1 is list 2, it'll be true. So let's look at an environment diagram of this because I think that's pretty helpful for this type of problem. So we define list 1 and list 2. So notice that they're separate lists. They're the same elements, but they're separate lists. And now they're obviously equal, but the identities are not the same because this one points to this list and this one points to this list. So these have separate identities, so as a result, it's false. So basically what the is statement basically does is we have to make sure that the pointer to the object points to the same object. So now once we do list 2 is equal to list 1, well now these point to the same object and we get that it is, when we check the identity equality, it's true. But if we check just double equals, it's always going to be true as long as they have the same elements. So that's the key idea here. Okay, then one more thing we're going to talk about is the isInstance function. And this can be useful for checking if an object is an instance of a class, of a particular class. So to show this, I'm just going to import the fraction class we've seen before, and I'm going to define half as fraction of 1, 2. And now, if I have to check, hey, is half an object of the fraction class? How do I do that? Well, I can use this isInstance function to help me figure that out. And I get true. So now if I define another number that's randomly just 0.5, well, what class is this from? Well, we can get that from looking at the type, and this is part of the class float. So this is not part of the fraction class. So if I check is instance of x, is x part of the fraction class? Is x an object of the fraction class? Then I get false because it's not. So that's the basic idea with isInstance. And we're going to use all of these today in this video. So anyway, what is a data structure at the end of the day? Well, A data structure is a way to represent or organize data in a computer for efficient use. And a spoiler is actually that we've already seen some common data structures. We've seen the Python list, we've seen the Python dictionary, and we've seen sets. A Python list is actually exactly a way to organize data. We put them in a list, and they have particular indices associated with them. And then with a Python dictionary, what we do is we take elements and we map them to each other. We show some relation between two ideas. So that's a good way to organize data. And sets are also interesting because we just basically make them unordered. We only allow unique elements, and that's another way to represent data. And these can be, as we've seen, these can be useful for different types of things. But today, we're going to talk about another data structure called the linked list. The linked list is a data structure that stores elements in a linear collection. Okay, so what does that mean? Basically, each element points to the next element, essentially. And a linked list at the end is defined to be either empty or it has a first element and the rest pointing to another linked list that could potentially be empty. So that's the jumble of words. So what does that mean? Well, look at this diagram. A linked list is defined as having some set of items, and it turns out that every item has a value associated with it, and also the rest of it. The rest of it points to another linked list that has an item, and then this has the rest of it, and this pattern keeps on going until we get to the end where there's an item, and then it points to nothing, the empty linked list. So basically, notice that the rest of a linked list is also a linked list. So this kind of has a recursive definition to it, and you'll see in this video that recursion is really going to come back hard when we work with linked lists because they're a very good way to process linked lists. Anyway, let's look at a concrete example of a linked list. So here we have this Python linked list that's the following 1, 2, 3. How would we define this as a linked list? Well, the way we would define it is, hey, I have an element 1, so this is basically a linked list 1 that points to another linked list that has the element 2, and points to another linked list 3 that has the element 3, and 3 points to the empty linked list because we're done at that point. So this is the idea of how we represent a linked list. Now, how would we go about building the linked list data structure? So that's the main question we're going to ask ourselves in this next part of this video, where we are going to basically look at how we define this linked list. So what we want, basically, is we want to have a class that takes in 2 parameters, and the parameters basically represent the split boxes here. So the first one is going to be our actual element, and then the rest of that is going to point to whatever rest we have. So here, notice that this points to a linked list that's made up of 2 and 3. So here we have 1, and then we have a linked list that's made up of 2 and 3. And then in this part, we have a linked list of 2, and the rest of that is a linked list of 3. So this is how we have this idea. And how do we represent the empty list? Well, we just don't give it a second argument. So how does that work? Well, turns out we're going to have to use default arguments. Okay, and so this class that represents the blueprint for the linked list is going to have a first element and the rest of it. So that's basically the definition of the linked list. So the first element when we initially have this link is going to be 1. And then if we look at the rest and we look at the first element of that, that's going to be 2. And then if we look at the rest.rest, we're going to end in .first. So basically we were here, when we go rest, we were here, and then when we move rest again, we're here. And so if we get the first element from that, we get 3. And then if we go to the very end of the linked list, we get the empty linked list. So this is all going to be defined in the constructive. So there's a lot of work to do in this constructive. Not really, but actually there's not that much work, but there's a lot that feels like it's being done. But it's actually not too bad. Okay. Then we're also going to have some way to represent the linked list. So if we evaluate link, we should get the following. So this is going to be involved in the repr method, and it should work for all types of linked lists. So link.rest happens to be also a linked list, so it should also print something out. And then one more attribute that we want is we want to find some way to use the built-in lengths function, just like the normal list. And we also want to find a way to basically index into the elements, because we should also be able to select items out of a linked list, just like we can select items out of a list. So this is going to be interesting because implementing this is something we haven't really talked about, but it turns out that it's very easy to do.